Good day, students. You are welcome to our class today. This is a BSc chemistry class for our students in Jss1. Okay, our topic today says mass number. So our topic today is a continuation of what we did last week. Last week, we were able to define an atom, look at atomic number as a function of number of protons in one atom of an element. Okay, so today we are going to look at another aspect of this atom, the one we call the mass number. Mass number. So the objective of this lesson is that at the end of this lesson, every student should be able to define mass number, state the difference between atomic mass and mass number, and do simple calculation on mass number. Okay, so what is mass number? We said that mass number is the number of an atom. Mass number of an atom is the sum of the protons and neutrons in one atom of an element. So what we are saying is that, just like last week, I was able to tell you that an atom has three particles. An atom has three particles, or what we can call subatomic particles. So these subatomic particles are named protons, neutrons, and electrons. I told you that proton is positively charged, neutron is neutral, that is, does not have any charge, and the electron is negatively charged. I also told you that the mass of a proton is equal to 1, and the mass of a neutron is equal to 1. But the mass of an electron is quite negligible. It is very minute, that it cannot be used for mathematical calculations in chemistry. So we have the proton and the mass as the proton and the neutron as the major contributors to the mass of an atom. Now, when we are talking about mass, we are talking about the weight, what it weighs. And if we say that a proton weighs 1 and a neutron weighs 1, that means if we have 1 proton and 1 neutron, it will be what? 1 plus 1, making it what? 2. So the mass number of that element or that atom will be equal to 2. Now, if we have an element which has 5 protons and 6 neutrons, what it simply means is that the atomic number of that element is going to be 5, because we are talking about number of protons. Remember, we said that the atomic number is the number of protons in one atom of an element. Now, if it has 5 protons, that means it has 6 neutrons, making the mass number 11. Okay, so that is all about mass number, the sum of protons and neutrons in one atom of an element. So whichever one that is given to you, you will be able to subtract or add the parameters given to you to get the answer you are looking for. So if you are looking for mass number, our mass number is actually proton plus neutron, while our atomic number is mass number minus neutron, and the number of neutrons is equal to what? Mass number minus atomic number, or mass number minus number of protons. So let's look at this image. I showed you this image last week during our video. I told you that this is a typical representation of a chemical element. So we use X to represent a chemical element and A as the mass number with atomic number Z written under it. So A is the superscript while Z is the subscript. So this is how we represent an atom in chemistry, showing the mass number and the atomic number. Even though most of the times what is being shown in most of the times or most textbooks will show you the atomic mass. If you go to the periodic table, what you'll be seeing is atomic mass and not mass number. Okay, so look at a typical mass number. We said that mass number is the number of neutrons plus the number of protons in one atom of an element. Now, looking at this picture, I want us to count the blue balls together and the blue and the red balls together to give us what our mass number is. So it's just simple. So I'm counting the blue balls now. I have 1, 2, 3, 4, 5, 6, 7, 8, and 9. I count again. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we have 9 neutrons in this atom. So we have 9 neutrons in this atom. Remember that each of these neutrons is weighing 1. Each of the neutrons weighs 1. Each of the neutrons weighs 1. So if we have 9 neutrons, that means we have a mass of 9 already being supplied by the neutrons. Now let's go over to the red balls, which represents the protons. Okay, I am counting now. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can see that here we have equal number of protons and neutrons. So we have 9 protons and 9 neutrons, making it, if you add the two of them, you get our 9 plus 9, which is equal to what? 18. That means this element or this atom weighs 18. Therefore, the mass number of this atom is equal to 18. I hope this is making sense to everybody right now. We add the number of protons plus the number of neutrons. It will give us the total number of particles or the nucleons in that atom of an element. Remember, we said that the nucleus is made up of the proton and the neutron, and this is where the mass number comes from, not from the electrons. Electron does not supply anything as regards mass, because the mass of one electron is very minute and negligible. Okay, so let's see if there is any difference. I have used atomic mass and mass number interchangeably, but they are two different things. Mass number is different from atomic number. So what is this difference between the two of them? We said that atomic mass is the average mass of an atom based on the relative natural abundance of that element's isotopes. I repeat again, atomic mass is the average mass of an atom based on the relative natural abundance of that element's isotope. While mass number is the mass of the total number of protons and neutrons in the nucleus of that element. Okay, let me explain the first point to you. When we talk about isotopes, there are some elements that exist as isotopes. That means what they do is that they have different forms of that element existing. What causes this difference is the number of neutrons. They have different number of neutrons. So let me define isotopy to you. Isotopy is a phenomenon in which atoms of the same element, remember, two different atoms but from the same element, existing with the same atomic number but different mass number. So when an atom of an element exists with the same atomic number but different mass number, remember that we said that mass number is when you add the protons plus neutrons, then you get your mass number. But now when you talk about isotopes, they have the same atomic number. That means they have the same number of protons but different number of neutrons, because it is the different number of neutrons that will cause the change in the number of the mass number. So when you have something like this, what you do is a simple calculation of addition and subtraction. So you either add or you subtract. That is when you are asked to find the mass number. Now, looking at isotopes, Now these elements, just like human beings, take for instance in Abuja, there are black people in Abuja. There are also people who are fair. There are people who are dark in complexion, and there are also people who are very fair in complexion. Now, these people who are very fair in complexion, they are small compared to the number of people who are dark. Now, this is what we call relative natural abundance. So, assuming there are 6 people in a particular room, 2 of them are fair, 3 of them are dark. Now, if you want to share them into groups, that means out of every 2 people or every 3 people, when you count 2 people that are dark, you count one person that is what? Fair. If you count 2 people that are dark, you count one person that is fair. Now, this is exactly what happens in isotopes. So there is a natural abundance or relative natural abundance, percentage abundance of this. So this 2 is a percentage of the total, while the other 2 or 1 is also a percentage of the total. So we cannot actually say that the dark people are 2, the ratio of 2:1 compared to the what? Fair people. That is what happens in atoms, in isotopes or isotopic elements. In this case, they have different mass numbers because this one has more neutrons than the other one. And because this one has more neutrons than the other one, you cannot just pick any number and say it is the mass number or the mass of that atom. What we do is that we take an average. Average means adding the whole isotopes together, dividing them by a common denominator. So when you divide them by a common denominator, you have the same, you have what we call atomic mass. Usually, atomic masses or atomic mass of elements are not usually whole numbers. But in the case of atomic number or mass numbers are usually whole numbers. So you see atomic numbers giving you decimal points, 5 point this, 6 point this, 7 point this, 8 point this, 9, 10, 11, and so on and so forth. So these numbers are not usually whole numbers. But in the case of mass number, you just add the number of protons plus the number of neutrons in that particular atom that was given to you to determine its mass. Okay, so let's look at a typical example. This is an exercise that we are going to do. So let's calculate the number of neutrons in one atom of sodium which has a mass number of 23. So the solution to this problem is simple. Just add atomic number of sodium is 11. Therefore, sodium has 11 protons. Now we say that mass number is equal to the number of protons plus neutrons. Now, having gotten 11 as our number of protons, because that is the atomic number of sodium, so all we do is 23 is equal to the mass number. So 23 is equal to 11 plus n. Our n represents neutrons. So our n will be equal to 23 minus 12, which is minus 11, which is equal to what? 12. So we can say that in one atom of sodium atom, we have 11 protons and 12 neutrons. That's giving us a mass number of 23. This is very simple. So I would want you on your own, after watching this video, go and look for other elements using the atomic number and having known their mass number. You can calculate the number of neutrons in each atom that makes it to have. There are some atoms like oxygen where we have 8 protons and 8 neutrons. The mass number of oxygen is usually 16. So there is no difference. But in most cases, or in some cases, the mass number is different. Sorry, the number of neutrons is different from the number of protons. In some cases, the number of protons is equal to the number of neutrons. So that is what happens naturally, and this is the simple explanation we are going to give to it. So I would want you to go home, or after watching this video, go and look for other exercises to calculate the number of protons in one atom of an element, or number of neutrons in one other atom of an element, or even look up online. You will see other examples so that you will understand the difference between atomic mass and mass number. Hello children, this is where we are going to come to the end of this class today. I would want you to do your exercises, practice it, and I hope that very soon that this lockdown will be over and we'll come back to school. You have a nice day and thanks for watching. Have a nice day.